Hello guys, welcome to my channel. I hope I find you well. In this video, we want to answer a question using two methods, okay? So the first method is trigonometry, followed by construction. So I will guide you step by step on how to use these two methods answering the same question, okay? So let's dive into it. Let me read here. If angle ACB equals 130 degrees and the length BC equals 7 centimeters, find the shortest distance from B to the straight line ACE. Okay, that's our question. So we want to find the shortest distance from B to the line ACE. We are given that this angle here is 130 degrees and this length is 7 centimeters, okay? So the first method which you are going to use is the method of trigonometry. So you are going to use trigonometry to find the shortest distance from B to ACE. Let me be quick to say that the shortest distance from B, okay, from this B to the line ACE is a line which starts from B moving towards ACE, and when it touches ACE, it forms a right angle. So it's a perpendicular from the point B, okay? So let us move on. Okay, here we are. So let me add some extra information here. So as I said, we want to use trigonometry, okay, to find the shortest distance from the vertex B. So this one, let me add this. Okay. As you can see, this line here makes an angle of 90 degrees with this straight line ACE. So that's the shortest distance of the line of the line from B to ACE. So let me call this point D. Okay, so that this one will be length BD. So in other words, we want to find the length of BD. That's the shortest distance of a line from B to ACE. So they meet at D there. So we want to find the length of BD. Okay, remember this one is a straight line, so it's a straight angle. And a straight angle adds up to 180 degrees. So if you say take 130 degrees from 180, here we remain with 50. We are left with 50 degrees here. So here is 50 degrees. Okay. Right, so we want to use trigonometry to find the length BD. Okay, so you can see here that we have a right angle triangle BCD. Okay, so we want to find this length BD. So from the what we have here, BD is now our opposite side, because it's opposite this acute angle of 50 degrees, and the given length BC, this one is our hypotenuse. So from SOHCAHTOA, here we want to pick the right ratio to use, so we are going to use the sine ratio, which is equals opposite side of hypotenuse. Remember, my BD is now the opposite side, okay? So here, I will say sine of the angle, my angle is now this angle C, so let me call it BCD, okay? the sine of angle BCD equals to opposite side of a hip, so hypotenuse, which is equal to, according to the length here, my opposite is BD over my hypotenuse is BC. Okay. Now I want to put some values. BD is no numerical value, it's the one which you want to find, over 7. Okay. So I mean to say sine of the angle BCD equals to BD over 7. So for me to find the length BD, I'll say BD equals to 7 multiplied by the sine of BCD, which is equal to 7 multiplied by sine, the sine of BCD. Remember, angle BCD is 50 degrees, so 7 multiplied by 50 degrees, which is equal to 5,4 centimeters, okay, to 2 significant figures. Okay, so that's the shortest distance of a line from B to the straight line ACDE. So they meet at D and they form a right angle there, or a 90 degrees. Okay, so that's the first method which I have shown you on how to finding the shortest distance from B to the line ACE. So the second method, we are going to use construction. Okay, we're going to use construction. So before I show you how to use construction, I will want to explain the construction, or to make you know the construction which you are going to use. So the construction which you are going to use to answer that same question is the one here. Let me read. It says a perpendicular to a line from a point outside the line. Okay, so a perpendicular to a line is the line which is being referred to here as to a line, and the point outside the line is this A. Okay, so I want to draw a perpendicular from point A to the line PQ. Okay, so for you to draw a perpendicular from a point outside the line to a given line PQ, in this case, I'm using my point A as the point outside the line. So I choose A as my center to my canvas and increase the radius of my canvas. And then let me go this side so that it becomes clear when you are following. And then I cut with A as my center. As you can see, I cut my given line. In this case, my given line is PQ. I cut PQ at 2 points. That's here and here. Okay, so let me try to put some additions here so that my axe can be visible. So I'll trace above the pencil markings so that my axe can be visible. This is where my axe cut the line. Okay, so I'll call these points maybe X, Y. Okay, so my axe are cutting the line PQ at X and Y. Okay. And then now, using points X and Y as my new centers, I'll draw another arc here without changing the radius, another arc, and choose X as my center. I'll draw another arc which cuts the previous arc. Okay, so let me just enhance this pencil line so that you can see them. Right, another arc here. Okay, remember I want to draw a perpendicular to a line from a point outside the line. And then I draw a straight line from the point A right through the point of intersection of the two arcs. Okay, let me use this one so that it can be visible. Okay, so this one is now a perpendicular from this point which is outside this given line PQ. So it means here this angle is 90, it's a right angle is 90 degrees. So after doing this, you can measure the length from A up to this point. Okay, so we are going to apply this method to find the shortest length from the point B. Remember what our equation required. Let me just bring it back so that you can remember it. Okay, our question was saying I want to find the shortest distance from point B to the line ACE. Okay, so I'll use the method which I've just demonstrated, the method of construction. Okay, so here we are. So the shortest distance of the line from B here to ACE is a line which comes from B and makes a right angle where it touches ACE. So now I'll start by constructing a perpendicular from the point B which is outside ACE, as I have demonstrated previously. So the B as my center, okay, with the B as the center, I'll cut line ACE at two different points. So let me enhance this one so that you can see the arcs. Here I've got the arc, and here we have an arc. Okay, so it's now better, a little visible, better in terms of visibility. Okay, with these ones, these are now my new centers where the arcs meet the line ACE. Are now my centers where the arc meets the line ACE. Okay, so I'll draw another arc without changing the radius. I'll draw another arc with the other side is my center now. Okay, right. So I now draw a straight line from the point B which passes through the intersection of the arcs here. Okay, so let me just enhance these arcs so that they can be a bit visible to enhance their visibility. Okay, so here we are. So the distance I want to find here, the shortest distance from of a line from B to ACE is from B up to this point. Let's call it again D again. Okay. So using a ruler, I will measure this distance from B to D. Let me zoom so that you can see roughly. Okay, yeah, it's a little bit better. So you can see the distance here is the 0 mark, 1, 2, 3, 4, 5. It's about 5.4 centimeters, as we saw earlier when we used the trigonometry. Okay, so using construction, we've realized that once again that we show the distance from the point B to line ACE. Also, let me call it BD, equals to 5.4 centimeters after measuring using a ruler. Okay, thank you for watching. Meet you in the next videos.